The last section which we are going to discuss in frame of this topic is a conceptual modeling. So first of all, I would like to point out that a conceptual modeling is the second step in the workflow which we have discussed, and we are going to dig inside and we are going to catch up what is the essence and necessity of having a conceptual modeling as a part of simulation modeling. At this stage, we work with a conceptual model. So, a conceptual model provides a simplified view of the system, highlighting only the key elements and their relationships. Its purpose is not detailed calculation, but to support understanding, communication and discussion of how the system works. So the question is a communication between whom? And the answer is really very simple. Between the analyst, so the person who is doing the simulation, and stakeholders, so probably owners of the company or top management or a specific person responsible for this project. Typically, conceptual models are expressed visually using diagrams, flowcharts, or process maps. They help ensure that everyone shares the same understanding before moving to formal or simulation models. At the conceptual modeling stage, we make assumptions and simplifications to handle uncertainty and keep the model manageable. Assumptions reflect what we believe about the real system when exact information is unavailable. For example, we may assume that all employees in department work at the same average speed, or that incoming work arrives at stable average rate over the time. Simplifications, on the other hand, are deliberate design choices. They reduce complexity so the model can be developed and used efficiently. For instance, several detailed tasks may be represented as a single processing step, or communication delays between departments may be ignored. The key idea is that assumptions and simplifications should support the modeling goal, while still preserving the essential behavior of the system. There are different ways to represent the same conceptual model, depending on the purpose and the audience. We usually start with a component list. So, a purpose of a component list to identify the key elements of the system and the parameters which are associated with the following items, such as customers, queues, service desks, along with arrival and service time distributions. A process flow diagram shows how entities move through the system, highlighting the main processing stages and their sequences. The logic flow diagram adds decision points, for example, checking whether there is space in the queue or whatever it is server available, making the system's control logic explicit. Together, those representations help translate real-world behavior into a model that can be later formalized and simulated. Okay, so now let's try to see some examples to catch up the idea of conceptual modeling. So the following figure represents a basic queuing conceptual model, which is widely utilized in a simulation. So entities are entering the system as arrivals, waits in a queue if the processing units are busy, and then leaves the system after the processing. So it seems that the following conceptual model is a bit generic, but to be honest, even the following simple conceptual model could represent quite a lot of realistic schemes. So let's imagine a logistics domain. A cargo vehicle arrives to a warehouse, so we're trying to catch up if loading and unloading ramps are busy. So if all of them are busy, so a cargo vehicle is waiting in a queue. If a ramp becomes free, so a processing is happening, and after processing, a cargo vehicle just leaving the system. Let's consider one more example, more complex compared to a previous slide. So the slide shows an example of conceptual model for a retail shop system. Customers first spend time in the shopping area, where the shopping time depends on the number of items we are going to buy. After shopping, customers move to one of 5 cash desks. Each cash desk operates with a FIFO queue and has limited capacity. The service time at checkout depends on the customer's basket size, while customer arrival follows a random process. The conceptual model helps us understand the system structure before moving to data, parameters, and simulation experiments. The following slide shows examples of simplification and assumptions regarding our second example of a conceptual model. Simplifications describes what we intentionally ignore to keep the model manageable. For example, we assume all customers behave in a similar way. Staff performance is constant and no unexpected events occur in a system. Assumptions describes what we explicitly fix in the model. We assume customers arrive randomly. The shop has exactly 5 cash desks. All queues follow FIFO discipline. Service time depends on basket size and queue capacity is fixed. So this one is our third example, but I'm not going to talk a lot about the following example. Let it be your small task. So you see the conceptual model. The hint for you that a following conceptual model is related with airport. Just stop the video and give yourself 5 minutes. Try to imagine what kind of processes or what kind of system the following conceptual model is representing. Okay, most probably you catch up that a following conceptual model which we have just saw represents passenger and baggage flow in airport terminal. So we have an arrival of passengers. It's most probably a random process. Passengers are selecting the shortest available queue among multiple check-ins. So a baggage is routed and checked for the security issues. Now again, a very small task for you. Try to think what kind of assumptions and what kind of simplifications we have applied for a following conceptual model compared to real system.